Hi, my name is Leah Marks, and I am a senior in material science in the honors program. And I am going to be talking to you about writing to learn in material science. And a little bit of background before I start this presentation. I got involved with this project as a writing fellow in MSE 250 in the winter of 2020. And so the professor teaching the course was already involved in this research, and she asked if any of the writing fellows would be interested. And so I took her up on that opportunity, and that's how I figured out what my capstone project was going to be. And what inspired me to complete this project was my simultaneous passions for engineering and writing. I'm a writing minor, and I'm really passionate about implementing writing instruction in engineering classrooms. So I felt like this project was a great fit. And then connecting with my capstone advisor, he was one of the professors on the research team that existed for this project when I joined, and he was also one of my professors in a course that I was taking at the same time that I was a writing fellow. So now I'll go into a little bit about my work, looking at the efficacy of implementing writing to learn assignments in MSE 250 specifically. And so the goal of this study was to enhance content learning, foster engagement with peers and instructors, and increase STEM participation by underrepresented groups. And so this pedagogy is inherent to the MWrite program. And so many of you may be familiar with that through other classes or even through MSE 250. But it's commonly implemented in STEM courses at Michigan to add another dimension to a curriculum that could otherwise be kind of monolithic and grounded in numerical problem solving. So the writing to learn approach you may be familiar with, again, from classes, just consists of an initial submission followed by peer review and then the final submission. And so what we did is we took data from 3 different semesters of MSE 250. And in 2 of those semesters, some students completed the writing to learn assignments and some didn't. And so for the students who completed the writing assignments, we took their submissions and scored improvement between the initial submission and the final draft using Cohen's d statistics. So that's just a metric commonly used in education research to determine the magnitude of, in this case, the effect of the revision process on improvement in writing scores. And then students in the course, whether or not they did the writing to learn assignments, also completed the same kind of standardized test at the beginning and end of the semester. And we separated scores into 2 groups, one for students who completed the writing assignments and one for the students who didn't complete the writing assignments. And we were able to gauge whether completing the writing assignments facilitated a greater increase in scoring between the pre and post test. And we measured that using the normalized gain statistic, which you can see in the bottom right of the screen. And so this is one of the writing to learn assignments. If you've taken MSE 250, you'll be very familiar with this. So this is the second to last assignment, I believe, implemented in the course. And this asks students to evaluate whether incorporating recycled content into backpacks or into a load-bearing application would be structurally sound, basically. And so this really probes students' abilities to understand the stress strain behavior of polymers. And so the first thing we did was investigate the improvement between the draft and revision submissions of the writing to learn assignment. And so we did this by breaking up criteria into 5 different categories. And so these categories were defined by course objectives or by just different areas within the polymers topic specifically that students have been shown to struggle with. And so you can see that the revision scores are consistently higher than the draft scores, which is good. And then we also see the D values, the Cohen's d values, which quantify improvement to the right of the score bars. And those values are all very high for education research, which indicates that the intervention of writing to learn was really effective in helping students grow in these categories corresponding to the rubric criteria. And so here are the assessment questions that correspond to those standardized tests given at the beginning and end of the course that relate to the polymers topic specifically. And so we broke down results for students who did and did not complete the writing assignments. And so the green is for students who didn't, and the blue is for students who did. And you can see that the gains, well, only the statistically significant gains are shown, and they only happen to be statistically significant for students who did complete the writing to learn assignment. So we see that because the gains are larger for the students who complete the writing to learn assignments versus those who don't, we can conclude that writing to learn provides an additive benefit to learning of the polymers topic. And then here's another example of a writing to learn assignment, which asks students to use a binary phase diagram to investigate why a lead tin solder doesn't melt. And again, we see consistent improvement among the 5 rubric criteria we defined specifically for this writing assignment. And again, the D values, which you see to the right, are really high for education research, which supports the fact that the intervention provided by writing to learn, specifically for the phase diagram topic, is effective in supporting further learning. So again, here are the assessment questions on that standardized test on the phase diagram topic specifically. So we looked at these to understand whether the phase diagram writing to learn assignment helps students learn better than not completing the phase diagram writing to learn assignment. Here we have the assessment results for those 3 questions broken down by demographic. And so the green again represents students who didn't do the writing to learn assignment, the blue is for students who did, and the orange is for this comparison question that we included, which was for the water phase diagram, which is a little different than the binary phase diagram. And we were just using this to gauge whether not teaching the water phase diagram would be fine, just because, or to see if the students were able to carry over the knowledge gained from the course about binary phase diagrams to the slightly different water phase diagram. And so we see that there is the students who didn't complete the writing to learn assignment for this first question actually showed higher gains, and for both of the first 2 questions, but the gain values are really high even for the group who didn't complete the writing to learn assignment. So we're saying that the writing to learn assignments are still very effective despite the lower gains, and we're still going to look into why these phase diagram scores are higher for the students who didn't complete the writing to learn. And then we see that there's little gain across the semester on the water phase diagram. Again, that indicates that students weren't able to extrapolate any of the learnings from the binary phase diagram teaching into this newer, unfamiliar water phase diagram question. So we'll need to figure out how we can implement further intervention to help students make those unfamiliar connections. And so finally, here's a summary of topics of the exam topics grouped by categories corresponding to the writing to learn assignments. So we covered the polymers and the binary phase diagrams in earlier slides, but then there was also a corrosion prompt and one relating to crystal structures, but the whole class did the crystal structures one. So that's why you don't see a green bar. And besides the binary phase diagrams, which again is weird and we need to look into that, we see that the students completing writing to learn scored consistently higher or showed consistently greater improvement on the assessment questions between the beginning and end of the semester. So we can conclude that writing to learn facilitates a large improvement in learning, which would then support further implementation of writing to learn in introductory material science. So thank you for listening, and I hope you learned a little bit more about why writing to learn assignments can really benefit engineering classrooms.